Hey guys, this is Mr. Beckstrom, and today I'm going to take a look at a problem from section 3.10. This is finding the derivative of inverse trig functions. So it's asking us to find the derivative of the inverse cosine of 8 over x with respect to x. So not only do we have to find the derivative of an inverse cosine function, but we also have to use the chain rule. So the inverse cosine function kind of looks like this. The derivative for that is equal to, when we're doing the cosine, for the inverse cosine is it's a negative 1 over the square root of 1 minus x squared. So it looks like this for the inverse cosine function. But since we're doing the chain rule, we're also going to have to multiply by the derivative of the inside function there. So we got a little bit of work ahead of us, and we're probably going to have to do quite a bit of math in here as well. So let's go ahead and get started. So I'm going to right away do a u substitution, make this thing a little bit more manageable. So let's go ahead and let u equal to 8 over x. 8 over x. And if I do that, then my derivative of u is going to be equal to, well, what's the derivative of 8 over x? I'm going to do that off to the side. I'm going to go ahead, if that's 8 over x, that's the same thing as 8 x to the negative 1, right? So that way I can use the power rule. So the derivative of that is, using the power rule, is negative 1 times 8x to the negative 2, which is just equal to negative 8 over x squared, right? Just simple power rule. I could use the quotient rule, but if I bring the exponent up, that makes it for an easy power rule. So the derivative of u, if I do that, is going to be negative 8 over x squared. Don't make things harder than they have to be. So doing that, then I can apply the chain rule here. So the derivative of this function here, using the chain rule, is going to be negative 1 over the square root of 1 minus u squared, right? And then times the derivative of u. So just kind of something like that, or du. Probably better to write du. But remember, those mean the same thing, times du. So I can write it just like this. So what does that mean? Now I'm going to try to save some space here, so I make a little arrow. Well, that means it's negative 1 over 1 minus, my u is equal to 8 over x squared times negative 8 all over x squared, like this. All right, so this is my derivative with respect to x, applying the chain rule. Now it is some cleanup time because they want us to probably simplify this. So that's what I'm going to be working on now. All right, so let's go ahead and do that. So negative, let's go right away. I can do the negative times the negative. So this thing is going to become a positive. So I'm just going to cancel out those two negatives right away. So I'm going to have 1 over, on the bottom here, this is going to be 8 squared over x squared. So I'm going to go ahead and make this 1 into an x squared over x squared so I can have a common denominator. This will give me an x squared minus an 8 squared all over an x squared, right? So I made the 1 into an x squared over an x squared. That's an 8 squared over an x squared when I multiply the 8 over x squared by itself. And then combining those two fractions under subtraction, you get x squared minus 8 squared over x squared. And then this is times 8 over x squared. Remember, we already canceled out those two negative signs like this. All right, so we're getting somewhere here. Now, this is 1 over. So this here, remember, if we have a radical like that, I can write this as one radical over the other. So the square root of x squared is actually just x, and not only is it x, but it's the absolute value of x. Why? Because it has to be positive. We can't take the square root of x squared and get a negative number, right? It always has to be positive, so we can write it down as the absolute value of x. And let's go ahead and pull that out as 1 over the absolute value of x, because we're going to want to kind of clean that up a little bit later. So we're going to write that as 1 over the absolute value of x, like this, times, and I'll show you why I'm going to do that in a second, x squared minus 8 squared. All right, so this was just that absolute value of x squared was on the bottom here over absolute value of x squared. I just pulled it out like this, and then we have times that 8 over x squared. All right, now I'm going to go ahead and multiply those together, and this I'm going to multiply by the reciprocal of that, so it's going to bring that absolute value of x to the numerator up here. So and the 8's going to stay on the numerator, so this is going to be 8 times the absolute value of x is going to be up on top over there, and on the bottom we're going to have this radical and the x squared, so I'll have the x squared down here, and I'll have that radical down there. So x squared minus 8 squared. 8 squared. All right, and the last thing that we can do is notice x squared is always going to be positive, and x is always going to be positive, so we can always take a positive factor out of both of those, right? So if x squared was 64, right, we could always take a positive 8 out of both of those, right? So x squared could never be like a negative 64, right? X squared could never be like a negative 100. So we could always take a positive root out of both of those, leaving a positive root left. So that means that I can leave a positive root left on the bottom, taking an x out of both the top and the bottom. So I can leave it as the absolute value of x left on the bottom, and I am done. A little bit of tricky stuff going on there, but if you just kind of reason it out, it'll start to make sense. And that, ladies and gents, should be your final answer. If you have any questions, let me know, and I hope you have a great rest of your week and good luck on the test coming up. All right, thanks, bye.